Rare earth elements have become essential to the future economy and security. They make possible the high-tech world we live in today, everything from the miniaturization of electronics to the enabling of green energy and medical technologies to supporting a myriad of essential telecommunications and defense systems. They are the elements that have become irreplaceable to our world of technology. Given their necessity in a plethora of technological applications, concern exists over whether supply can meet the needs of the economy in the future. Rare earth elements are a group of 15 elements referred to as the lanthanide series in the periodic table of elements. They are the metals that have become irreplaceable to our world of technology owing to their unique magnetic, phosphorescent, and catalytic properties. These materials, many of which were of little economic interest until recently, are required to fuel a proliferation of technologies and industries that have become vital for social and economic well-being the world over. Growing reliance on critical and rare earth minerals by nearly all industrial sectors, including military and defense, has intensified global competition to identify new sources and establish stable, long-term supply chains of these natural resources. The rare earth element supply chain has been a worry for US-based high-tech companies and defense contractors for years, mainly because China controls 80% of rare earths supply and 90% of the complex processing required to transform rare earths into the magnets and powders in which they ultimately end up. To counter the reliance on China as the primary source and processing of rare earth metals, a bipartisan piece of legislation introduced in the US Senate, which would force defense contractors to stop buying rare earths from China by 2026 and use the Pentagon to create a permanent stockpile of the strategic minerals. However, the United States has only one rare earths mine and has no capability to process rare earth minerals. Canada, on the other hand, has some of the largest known reserves and resources, rare earths in the world, estimated at over 14 million tons of rare earth oxides in 2021. Rare earth minerals are processed primarily from ores and minerals that naturally contain uranium and thorium. Processing rare earth minerals involves the separation and removal of uranium and thorium. As such, new rare earth discoveries are being made in the Beaver Lodge Uranium-Thorium district of Northern Saskatchewan. Appia Rare Earths and Uranium Corporation S.L.'s Lake property, 34 kilometers east of Uranium City, has recently reported some of the highest REE grades in the world. Average zone high grades range from 4.2 to 32.2 weighted percent total rare earth oxide, or better known as TRIO. Appia's rare earths are associated with pegmatite, which is the host rock for many rare mineral deposits. Also, airborne radiometric surveys have proven to be an effective and valuable tool for delineating potential rare earth metals. Appia's rare earths exploration has focused on pegmatites within thorium anomalous areas. Belmont's Crackingstone property has similar geological and geophysical features to that of Appia's Alsa's Lake rare earths property. 2008 drilling intercepted pegmatite in 17 of the 20 holes drilled. The pegmatite intercepts appear to be structurally controlled by the Boom Lake Fault and associated with a thorium anomaly at surface. There is also a pegmatite outcrop east of the drilling which again appears to be associated with a thorium anomaly. Pegmatite occurrences were not reported extensively or assayed in the past because of their lower concentration of uranium values, which was the main focus of exploration. Also, as there was little global interest in rare earths at the time, rare earth potential of these pegmatites were never evaluated. In light of new global concerns as to whether current supply of rare earth metals can meet the needs of the global economy in the near future, Belmont Resources is planning a rare earths-focused exploration program for 2023. The program will consist of the following: 1. Relog 2008 drill core and re-assay for rare earth metals intervals containing pegmatite. Belmont has over 3,000 meters of 2008 drill core stored at Uranium City. Initial review of 2008 drill logs shows over 170 meters collectively of pegmatite intervals throughout 17 drill holes. 2. Sample known pegmatite outcrops. 3. Geological mapping of thorium radiometric anomaly in northwest area of the property. And 4. Delineate and sample new pegmatite showings for rare earths. Belmont Resources is looking to become a major player in the uranium, thorium, and rare earth metals exploration and development sector.